Okay, here's the problem: probabilities of permutations and combinations. There are 9 acts in a talent show. A comedian, a dancer, a guitarist, a juggler, a magician, a pianist, a singer, a violinist, and a whistler. The talent show is going to randomly select these acts, and we're going to compute the probability of each of these events. So the first event is that it chooses event A, the dancer's first, the juggler's second, violinist is third, and the magician is fourth. After that, it's just whatever happens to be. So this is kind of the way I see this. This is, there's 9 acts, 3, 4, 5, 6, 7, 8, 9. Now, if this was just done randomly, completely randomly, we would have 9, 8. We would choose 1 at 9. We'd have all 9 choices for the first one, but then we choose 1, so we only have 8 choices after that. And then we choose 1, so we only have 7. And then we choose 1, so we only have 6. Again, 5, 4, 3, 2, 1. So they've all been chosen. Now we're actually defining who the first one is. So that's one choice. And then, so we don't have that choice now. And then we've chosen. So that was the dancer, now the juggler. So 1. And then the violinist. So now we choose that. And then the magician. And that's 1. So then everyone that's left, there'd be 5 choices out of what's left. Then we'd choose that one, and then there'd be 4. And then we choose that one, and there'd be 3. And we choose that one, and there'd be 2. And then we choose that one, and there'd be 1. And so what we end up with is, well, this 1 over 1 is just 1. And these are all really multiplication that's happening between all these. But something that happens is that this piece is 1. So is that piece. So is that piece. So is that piece. So is that piece. So each of these is 1. 1 times anything is itself. So I'm left with 1 up top, 9 times 8. What is that? 72 times 7. Times 42. So that's going to be 9 times 8. Let's see. Let's do it by hand. Let's do it by hand because we can. Let me put it, where do I want to put this? So this will work. All right, 9 times 8. Let's do this. That's 72. 7 times 6 is 42. So I'm looking at 72 times 42. And I maybe have a different way of thinking of this. So I look at it like this. This is how I do multiplication, just as a little hint into my brain. That's kind of messed up anyway. 8, that's 28. And then 72 times 2, that's 4. That's 14. And then just add those up. So 2. 80, 144, and then 2, carry the 1, that's a 0, that 3,000. So 1 over 30, 24, and they want you to give this answer as a fraction in simplest forms. That is so that's the probability. This would equal the probability of event A happening. It's obviously pretty small, and we shouldn't be surprised about that. So now let's look at, let's see if this will work. There we go. Let's look at probability of event B. So we have the same situation. 3, 4, 5, 6, 7, 8, 9, and there are 9 choices, and then we choose 1, so there's 8, then we choose 1, so there's 7, then we choose 1, so there's 6, 5, 4, 3, 2, we know the last person. And now we're told that the first 4 acts are a singer, violinist, guitarist, and a dancer, but we don't care the order. So it's one of these 4. 1, 2, 3, 4. So there's 4 choices first. And then we choose one of those. Say we choose the guitarist, so now we have 3 choices. And then we have the singer, violinist, and dancer. Maybe we choose the dancer. So now we have a singer and violinist, so we only have 2 choices. And then whoever's last is last. Okay. And then out of everyone that's left, the other 5 acts, we still have to choose them. And we can choose them in any order. So 5, and then we choose 1, so it goes away, and we have 4 choices. We choose 1, so it goes away. 3, 2, 1. Same thing's happening. It's all multiplication, and these are 1. So they all go away. Well, they all become 1, and 1 times anything is itself. In this, we can do some simplification here. So let's see. There's nothing here that filters to 1, but remember, this is all multiplication. And because of that, I could go, well, there's a couple of choices, but I'm going to use the 4. 4 divided by 4 is 1. 1. And then 8 divided by 4 is 2. And then, well, I see a 2 and a 2, so 2 divided by 2 is 1, and 2 divided by 2 is 1. And then I have a 3, so I'll use it. 3 divided by 3 is 1. 9 divided by 3 is 3. So 1 times 1 times 1 times 1 across the top is going to be 1. And 3 times 1 times 7 times 6. Well, again, 7 times 6 is 42, so times 3, that's going to be, let's see, this is going to be 42. And then times 3, that's going to be 6 and 126. Yep, and this is again a fraction in the simplest form. And this is equal to the probability of event B. Now, I could have for sure used some other options for this. This is, let's see. So on A, well, yeah, let me do this one first. So this could have been used the NCR button. In this case, N would have been 9, right? So N would equal 9, and then R would equal, what would R equal in this case? R would equal the 4 choices. And it's really based on these 4 choices, these first 4 acts, 4 choices, so 4. And that would do the same thing. It would give you the only thing is that this is really this. It's 1 over the NCR. This is going to give you the possible combinations. And then that would still equal 1 over 126. You do have to know that this is how this reads to make this make sense. And then I think I can go back. Let's see. There we go. Okay, so on this one, this is event A. This would be an NPR, in which case it's a permutation. We do know the first 4, but it's the same idea. So N is equal to 9, and R is equal to 4. And again, it's 1 over, so this is going to equal 1 over this, which is going to be the same thing. It's the number of combinations. I think the first way I showed it is the easiest to kind of get to on your own without having to memorize, like, oh, which one's which? Do I need to use the NPR? And do I want to know how many choices there are, or do I want a probability of it? And so this first one kind of saves that idea. Let's go through all the possible choices. The bottom is possible choices right here. And the top is actually what you have. And again, what you have. And we just go through, we fill them in. My hope is will help you and guide you in completing this particular type of assignment or type of question. All right. Have a good day.